Growing plants is getting harder, more expensive, more complex, increasingly more difficult. I'm Chad Masura, CEO and founder of Rosie, and this is How We Grow. Hey everyone, this is Chad Masura from How We Grow, and I'm excited to have Karl Strahl on the recording with us here. Karl works in biochar commercialization and business development at Oregon Biochar Solutions, with a practical execution-first perspective on what it takes to scale biochar as a consistent input. He's helpful for growers and operators because he focuses on the real-world constraints, product specs, batch-to-batch consistency, logistics, economics, and fit for special use cases. Karl is one of our suppliers here at Rosie Soil and is one of my go-to experts whenever I have a biochar question. He's a legend in the space, and we're excited to have him on today. Welcome, Karl.
Thanks, Chad. Thanks for having me.
Excited to have you. So let's start simple. I think biochar as a term is thrown around there all the time, and I'd love to hear, directly from the horse's mouth. Like, for someone who keeps hearing biochar, what is it in plain English? And I think importantly, also, what is it not?
It's a good question. I think if you take the name apart, you kind of get a good idea what it is. Bio and then char. So it's a char material, a charcoal material made out of plant matter. And when most people think of charcoal, they are going to think of charcoal briquettes. That's a class of material that also falls into biochar, although most charcoal briquettes will also have some other coal materials in them. I think for the majority of the audience, when they think of biochar, they're thinking of it in terms of its applications to soils. But there's a lot of other markets out there as well. I mean, in the range of products biochar material encompasses are, filtration products such as activated charcoal. And activated charcoal, can either be made out of a plant-based material, a wood or coconut shell or other material, or they can also be made out of coal-based products. So you can take a bituminous or an anthracite coal and modify them. So it kind of occupies this space in a category of carbon products. It is not a silver bullet, doesn't fix all of your problems, but it's a very, very useful tool to have in agriculture, in filtration, in, various different markets. It can even be used for, as a replacement for coal and steel production. So it's a versatile product. There's a lot of different types of biochars that can be made for different applications, and depending on what you make, they will work better or worse or not at all in a range of different markets.
Yeah, great. And what got you excited about biochar in the first place? Like, tell us a bit more about your background and how you ultimately sort of stumbled into the strange and fun world that is biochar.
For sure. So I started in 2017. Out of college, I'd worked for Solar City and then briefly for Tesla Solar. And I came across biochar through a sibling who knew somebody that was in the business, and started to look into it pretty seriously and realized that...
And this is just, are you just nerding out kind of on the internet and reading textbooks and that sort of, like, were you a big sustainability person? And obviously your background at Solar City, is that what sort of brought you to biochar in the first place, or what got you really excited about it?
Well, I mean, I'm looking for practical approaches, practical solutions to the issues that we face. And, I am sustainably minded. I think that, we have a finite supply of fossil fuels on this planet, and we need to find alternatives. And if the alternative is cheaper and easier to use, then that's usually a win, both from a environmental standpoint, but also from a product standpoint. I like seeing better, cheaper, more sustainable products that, help out the users. Mm-hmm. But yeah, so the pathway was, I think it was in June of 2017, found out about biochar, realized I'd heard about it before in college, but had been focused on more technical products, and then did some research, realized that, this is a new emerging market. Seemed to be a lot of very, very small startups in the space, and figured it would be a good place to work. It sounded like something that was very, very beneficial if it could be implemented.
Cool. And so what did that look like for you? Like what were the early days of your career in biochar, and how has it evolved to, where we are here today in 2026?
Mostly researching what biochar was online, and making the classic mistake of reading research papers and assuming that the product that we made could do what those research papers said it could.
Yes. Well, you can find a research paper that will say just about anything about biochar. So especially if you have some selective bias, you can go down various rabbit holes.
Yes. Well, and that was actually a really good learning moment for me, because I would read the paper and then try and test our biochar in that situation. And sometimes it would work and sometimes it wouldn't work. And that's when I had to step back and say, basically, this is a class of materials, right? It's like activated carbons. You're not going to expect a vapor phase activated carbon to perform in a aqueous phase, situation. So it was very, very interesting. I learned a lot very quickly, and then had to unlearn a lot almost equally quickly, and really start to dive into what product it is that we were making and what applications it had.
Great. Yeah. And that actually takes me to my next question. And I was curious your perspective on this, but when you're talking to a grower today, what are kind of the, call it 3 to 5 specs that you think really matter? Like, what are the things they should be looking for in a char, really within this class of materials, that will make the most benefit to their soil health or their plant outcomes, or whatever that core outcome may look like?
I think if you had to condense it to 3, I would look at H to C ratio. Then I'd look at water holding capacity, and then I'd look at probably nutrient holding capacity. There's also the safeties. So I'm going to expand 4 and 5, actually, and change this to number 1. Number 1 is you should probably look at what's in the char and just make sure that there's no, extremely high levels of heavy metals or something like that in there. In the United States right now, I have not found any biochars like that, but it is possible, and I think it's always a good idea to do a little bit of due diligence. So
that's maybe a filter criteria for you. First and foremost, make sure there's no heavy metals. Nothing dangerous.
Heavy metals and residuals, from production process, the safety checks. Then look at, the HC ratio, which is going to tell you how hydrophobic it is. So usually the lower the HC ratio, the more hydrophilic, although I'm using that word incorrectly, but more readily it absorbs water.
And is there an ideal range you look for or generally recommend?
Yeah, there's going to be a range, probably below a point. Let's see, what would be a good? I'm used to dealing with just our materials, but I think probably between 0.18 and a 0.24. I think I've got those units correct. I should probably double check.
We can add it to the show notes too if we want to change our minds. But generally, you're saying that's indicative of the water holding capacity, which I think is what you put number 2.
Well, not indicative of the water holding capacity. It's indicative of its ability to readily absorb water. Water holding capacity is a different test. So A, you want to make sure the material doesn't repel water, and then B, it's very useful to know how much water it holds inside of its pore structure.
Okay, cool. So HSC ratio, water holding capacity, make sure there's no heavy metals. Anything else you think folks should keep an eye on before they, jump into trials?
pH. It's good to keep an eye on the pH of the material, because that will have an effect on the growing media, and whether it's high or neutral low, you'll need to treat that differently.
Yeah.
In terms of agriculture, surface area can be a useful number to look at, but it's not the most important thing to look at.
Yeah. Yeah. And you can start to get into if it's micropore dominant or macropore dominant, but I do agree. I think the base level of characteristics that you described, I think, were important. What about feedstock? How do you think about feedstock? How do you think growers should be thinking about feedstock? Does it matter?
What was the feedstock that was used to make terra preta?
A bunch of random stuff, from what I understand.
Yeah, I think I'm not sure that I'll make a lot of friends saying this, but what I think is important is that's a good clean material, readily absorbs water, adsorbs water, is safe to use in the soil.
Yeah.
There's going to be some differences between different biochars initially. Different biochars are going to react with the soil in different ways. I think if you're taking a much longer view, I think probably after 20 or 30 or 40 years, I don't really have data to tell us exactly how long. I think a lot of them are going to perform very similarly as, the pores get filled up and oxidized, and the CEC will continue to increase in the soil after you've incorporated the biochar in. In terms of initial performance, there's going to be a difference between biochars. Yeah. And in cases that can be very important. But if you're incorporating it into the soil year after year at a fairly low level, I think those differences are less important than actually increasing the carbon content of the soil.
Yeah, yeah. And so is your general recommendation to try to find a local high quality char? It depends on, what the raw materials or the organic waste looks like in whatever region you're growing in, and stick to some of the specs that we were talking about earlier, versus getting stuck on, one specific type of char or another.
Yeah, I think, depending on what you're doing, if there's a local high quality char available and it meets your needs, that's usually the best way to go. There are some specialty markets within agriculture where you have to be very careful what type of char you're using and the performance of it, but those are less mainstream.
Yeah.
And then, if possible, I always recommend you co-compost the biochar before you add it. It just seems to, across the board, improve the performance in years 1 to 3.
Yeah, great. So let's talk about that. Tell me about, since 2017, which in biochar years is very long. What are, as you've seen trials go well and not go well, what are some of the key characteristics there? Like, what are growers doing well in initial trials with biochar that makes things successful, and where in your experience do trials go wrong?
I would say that some of the greatest successes we've had have been in fairly odd circumstances, meaning that we saw a great deal more performance than we were expecting. One of those was at a cotton farm in Northern California, and during drought, the fields with biochar incorporated in them managed to get some harvest off of them, versus the fields that did not have biochar incorporated into the soil did not really yield anything. What was interesting was, because this was, kind of the early days, and the farmers are somewhat hesitant to make a major change in their fields. The biochar had been applied to what the farm manager had described was their worst fields, and in with the soil were like little chunks of concrete and other unwanted materials that were just on the site when the farmer had started growing there. And I think we had used, it was less than 1,000 pounds per acre treatment, which is not a huge amount of biochar. And actually having a harvest off there was quite impressive. And the reason the farm had a number of different crops and had a limited amount of water to use to irrigate those crops. So they had cut water to a lot of their cotton fields. So it was very interesting data point. Not a really scientific study. I think that could be researched a lot further, seeing what's the lowest amount of biochar that can be used to actually reduce drought stress on crops. But yeah, just it's always stuck in my mind that, can sometimes get a very unexpected result.
Yeah.
And then things that haven't worked, if you have an in-ground irrigation system and you top dress with biochar, that's not going to work. And that happened during there's a university extension that had done some research with biochar, and they had incorporated the biochar in like the first 1.5 to 2 inches of the soil. And there was a below ground irrigation system, like drip irrigation system. And I think what was happening was it was wicking the water up to the surface and evaporating. So do not recommend.
Yeah. Awesome. And then what about economics, right? So I think that's the core conversation now, which is, historically biochar has been really expensive, although we're starting to see prices come down. I'm curious where, in 2026 prices, where you see biochar working economically, and where you think, the market is sort of still holding out for the promise of a cheaper char.
I think I really see biochar working out as a additive into agriculture at a very, very low level every single year. And it can be mixed in with other components that are being spread in the fields, fertilizers, composts, and the cost can be cut down, essentially by
Purely on volume, you're saying?
Purely on volume, much lower
acre.
volume application per acre, in with other materials that are already going in. And then you can build up that content, over decades of use. You'll really start to see a change in the soil's carbon contact. And a lot of farmers are looking to leave good cropland. If they've got kids that are going to continue the farm, they are always looking for ways that they can improve the land. And so this is a much cheaper approach to doing it. Less biochar, done every single year, with other amendments that are complementary.
Yeah. And is there a minimum recommendation you're making? Like, is there a certain tonnage per acre that you think is a good starting place that's not going to break the bank, but where folks will start to see at least some impact over the next 2 or 3 years?
It's a good question. There's a lot of nuance to it because it depends region to region, soil type by soil type, what they are actually looking for. So in soils that are more on the clay side of things, farmers are going to look for increased drainage. And if they have a very sandy soil, they're going to look for increased water retention. And application volume and depth are both going to be affected depending on what you're trying to do. In terms of the total content that you should be looking for, I think there's some pretty decent data out there showing that carbon content above 20% in soils has diminishing returns. Mm-hmm. You also don't want, you need other components in there for plants to live. So you can't grow in straight biochar fields. So there's going to be a range. I think a good target for the next 20 years is to get the carbon content up 3 points.
Yep.
3% up across the majority of agricultural fields in the US. And it's an enormous amount of biochar to get there. But that will have a statistically significant reduction in fertilizers needed, and quite possibly in water needed. I think that's a good target to look at, and that means that, if you take 3% divided by 20 years, that should be the amount that you're looking to incorporate in. But that's a guesstimate. A lot of this hasn't been thoroughly enough researched at this point for us to have a really confident answer. The only thing we can do is we can look at other, soils that have had, pyrogenic carbon in them. And the Amazon, the Terra Preta soils are a good example of that. And then there's other areas of the world where we found that as well.
Yeah, great. And I think that leads into my next question. And it sounds like research is a key, let's call it blocker. But what do you think is slowing down biochar adoption, both here in the U.S. and globally? Like what perhaps alongside the lack of deep research is holding things back?
I don't know that there's anything holding it back per se. I think that farmers are cautious. Their soil is their livelihood for farmers that grow crops, and so they're not going to try any new innovation and try it at the entire scale of their farm. A lot of them are watching, learning, maybe buying some, trying it out in limited areas to see how it works. And there are a lot of research trials in place that are actually starting to generate usable data. I think getting the word out is probably the most important thing we can do to accelerate the adoption. Really showing farmers what has been done and backing that up with data is very important. As we start to see more and more extreme weather events, hotter temperatures during the summer, colder, wetter, rainier winters, or drier winters, depending on which region you're in, I think you're going to start to see a lot more interest in the climate irregularity, the general weirding of the weather patterns.
Weird weather,
Yes. So unpredictable weather patterns. Farmers are going to start to really look for ways that they can add an insurance policy to have a higher chance of having a successful crop. Mm-hmm. And I think that's where it can really help out. I think, once we have 5 to 10 years of good data, I'm guessing that crop insurers are actually going to be very supportive of using biochar in soils. It reduces
for buffering capacity effectively is what I'm saying. Yeah.
Yeah. So if there's a drought, then there's a higher chance of a successful crop, and I think that would be something good to study with some of the institutes that inform insurance companies on what are coming risks. I think that would be a good study to be done in combination with them.
Cool. Maybe outside of ag and hort, just because I know you're thinking about biochar much more broadly, what are some of the avenues you're most excited about? What are some of the things you're thinking about for the coming years for this market? Remediation's
a big one. Remediation, stormwater filtration, asphalt, of course, and other products in the built environment. Those are going to be large users of biochar in the future.
Yeah. And do you think those use cases potentially support bringing down the cost of char for growers as well? Like, is that a forcing function that you see that helps make this important material more accessible for everyone?
I think it will, in terms of volume of biochar produced. Mm-hmm. And I think, there's going to be enough folks out there building new plants where they don't build their plant to specifically produce a char for a certain application. They'll want, a little bit more flexibility in the grades that they produce so that they can pivot char from one market to the other depending on demand.
Sure. Yeah.
So asphalt, once that market really starts to get going, we'll have a huge demand for biochar. Filtration is already starting to see, higher demand for biochar in bioswales and, other stormwater catch devices. I would also expect to see a lot for remediation, because in most cases it's a cheaper alternative to activated carbon and other technologies that are employed. And in some cases, it can be combined with other, activated carbons or other remediation tools to get a better and sometimes cheaper cleanup.
Yeah. Cool. And what have been some of the challenges along the way for you just in scaling on the production side? What have been some of the big bottlenecks you've run into or things you've had to overcome? And what are some of the ones perhaps you see on the horizon as well that we should be aware of?
On the production side, when we built out our facility, there was not a lot of technology to choose from. So finding out what equipment could actually handle biochar in terms of conveying and bagging and all of that, there was a lot of trial and error, both on our part and on the engineering support part, because carbon is, fairly abrasive material. It's also dusty. And if it's not quenched, properly, an ember can smolder for days and then start a fire in a bag or a hopper or something like that. So there was a lot of thought and research that was put into actually how to safely produce and extract, transport this material. And that's led us to have a much better understanding of, what types of equipment work best for that. Growing pains, I think a lot of it has been looking at what biochar-based products to support the most. So, biochar can go into a lot of different materials. It can be a seed coating, it can be an amendment to, horticultural soils or, bagged soil media. It can be a component of, filtration or asphalt or a lot of other products, and pick which markets to push into and then stick with that and really push the research and product development forward. Takes a lot of time and effort. And, I recommend that if folks are just starting off producing biochar and trying to find places to sell it, pick 1 to 3 applications and become an expert in it. And just those 3, or better, 1, if you're very confident in that one. I think there's somewhere between 40 and 600 applications for biochar, depending on how broadly you want to use the term. Sure, and yeah. That would be a lot of knowledge to try and build up. Totally.
Yeah. Cool. Well, anything you want to leave us with? I guess, what are you, as you're thinking about the future of char, what are you super optimistic about? And also, as we wrap, how can we support the important work that you're doing at Oregon Biochar?
I'm really right now. I'm really excited about the asphalt market. Can't talk too much about that, but we're seeing some pretty promising results. Also, very, very excited about the potting mix side of things. Biochar is, as you know, it has a lot of benefits to residential and commercial potting soils, and remediation.
Yeah,
remediation has a lot of potential, and it's going to take a lot of work to get to the point where we can confidently sell large volumes into that market. But I think the biochar industry as a whole has done a good job pushing into that space and really proving out its benefits.
Great. I love it. I love it. Well, how can we support the work you're doing at Oregon Biochar?
Keep talking about biochar.
I promise you I will. I promise you I will. And you know, for the listener, like how can we support? How can we follow along? You know, are there any products we can be pointed towards? Anything like that?
Well, if you'd like to buy some potting soil with biochar in it, you can go buy some from Rosy Soils.
I promise you that was not an intended plug, but yes, you know, we're a very happy customer of OBS.
Yep. And then on the other front, you know, if there is a remediation project going in, if there's new stormwater management projects going in, if you reach out and talk to the contractors or talk to your local or state officials and ask them if they've evaluated a biochar to use in that, that would be very helpful. The projects that have gone in have all been successes to the best of my knowledge. It's quite easy material to use, and in cases can actually bring down the overall cost of the project.
Great. I love it. Well, Karl, thanks so much for joining us here today. It was a pleasure as always to chat with you, and yeah, keep up the great work.
Thanks, Chad.
Thank you.
You as well.